Hi, and welcome back to 5-Minute Chemistry with Always Eclectic Stacy. We're working on the covalent bond series, and this is the 7th example of how to take a covalent name and write it into a molecular formula. Let's get going. Welcome back to Always Eclectic Chemistry. This is the 7th example for their VSEPR and Lewis structures, and today we're looking at SbI₅. If we were to name this properly, it would be Antimony Pentaiodide. So we're looking at Antimony Pentaiodide. Now, if you're wondering why it has 5, antimony is a little funny. You can have something called an expanded octet, which means it can support more bonds than it's supposed to be allowed. It likes to bond a lot. So, first thing we're going to do is we're going to go ahead and draw the Lewis dot of antimony, which is Sb, and it has supposed to have 5 valence electrons, so it's 1, 2, 3, 4, 5. I did that wrong. Remember, it's supposed to be right, left, up, down, right. And then because it has 3, that's almost always going to go in the middle because I know iodine is a halogen. It only has 1 bonding potential because it has 7 valence electrons. And if we look at the polarity of both of these, Sb, or antimony, has a polarity of 1.9, and iodine has a polarity of 2.5. And if you're wondering why I'm putting iodine on top, it's because I always put the one with higher polarity on top for easier math. And 2.5 minus 1.9 is 0.6. So it should have a slight polarity, but because there's so many iodines, we're going to hold off on calling it polar or nonpolar until we see the molecular geometry. So Sb goes in the middle, and normally I'd say, you know what, draw all your bonds. But for this one, this bonding pair gets broken up, and every single dot on Sb gets used, or antimony gets used to bond with iodine. So we're going to just go ahead and draw 5 lines off of Sb, 3, 4, 5, and attach each of those to an iodine. And I know this feels funny and it feels weird because it's an expanded octet, but that is how it's supposed to go. For each iodine, don't forget to draw in your extra Lewis dots or valence electrons so that you can represent every single electron in the molecule. For this one, we have 5 bonding pairs. 1, 2, 3, 4, 5. So we have 5 bonding pairs. There's no lone pairs on Sb. Don't look at the lone pairs on iodine. We're only looking at the central atom. So no lone pairs. So when we look at the shape again, it's going to be trigonal bipyramidal. This is your molecular shape. And now, notice how all the iodines are equally spread out. It should be slightly polar, but because they're pulling kind of opposite, it's going to cancel out that polar moment or that dipole moment. And this is going to become a non-polar molecule. Now, if this was antimony triiodide, it would be polar. It's the 2 extra iodine that make it non-polar because it's able to cancel out the pull to one side. Thank you so much for watching. If you like this, please don't forget to like and subscribe and follow my channel. Have a great day.